In this video, I'll show you how to model joint variation using multiple variables. The question reads, if y is directly proportional to the square of x and inversely proportional to the cube of w, by what factor will y1 change if x1 is increased by 15% and w1 is decreased by 20%? Let's model our equation as y is equal to k for our constant, and we're told that it's directly proportional to the square of x and inversely proportional to the cube of w. So that is represented as w cubed. By what factor will y1 change if x1 is increased by 15%? So we're told that there will be a change to the x and to the w, and the change will be represented as x1, and that is equal to an increase of 15% of the original x. So we can represent that as 1.15 of the original x. Since there's a 15% increase, the original amount of x will stay the same and 15% will be added. And the way you represent that with percentages is you say 1, your original, plus 0.15, which is 15% converted as a decimal, and that's where 1.15 came from. Similarly, w, or our change in w, will be decreased by 20% of its original. That can be represented as 0.8w. Pretend that we had 1 and we're minusing 0.2, 20% of the original. You get 80% of what you had originally. Y, or the change in y, will be represented as y1. So let's rewrite all of these variables with the variable and the subscript 1. y1 is equal to k x1 to the power of 2 and w1 to the power of 3. Replacing this and this with these two gives us y1 is equal to k 1.15 x to the power of 2. Notice that I replaced this expression into here, over w subscript 1 will become 0.8 w to the power of 3. Next, what I'll do is distribute this 2 to both of these components and 3 to both of these components, giving us 1.15 to the power of 2, and that's equal to roughly 1.32. So y subscript 1 k times 1.32 x to the power of 2 is x squared, over 0.8 to the power of 3. That gives us 0.512. 0.512 w to the power of 3. I'm going to rearrange this part so that 1.32 is at the front. And once you've done that, you'll actually notice something, that this part of the expression is equal to the original y. This means that y will change by a factor of 1.32 over 0.512. Or in other words, 1.32 divided by 0.512 gives us 2.57. So y will change, the original y will change by a factor of 2.57. And so there you have it. That is how to model joint variation using multiple variables.